So welcome everyone to the launch of the MSSI initiative here at McGill. It's a great pleasure to be here to introduce some of our work to launching the materials theme that will be within this initiative. So Anya mentioned the challenge that the Dean had thinking about how to change the way we practice things and change the way we are thinking about the grand challenge of sustainability. So my colleagues George, Neil, and I were tasked with trying to find a mechanism to doing this, and I'll try to show you what we came up with in this framework. So our grand challenge here is to recognize, in fact, a contradiction that we're in, that the society demands that we create constantly novel materials to address the needs of the society, to address the fact that we're facing major challenges in terms of energy, global warming, or just living our lives, food, health. However, one of the big problems is that it's been recognized that some of these materials later down the road leave a legacy and cause pollution, toxicity, and we only realize this much later, when it's too late, when they've already done a lot of damage, and everybody also has gotten used to the technologies and the way they function that has created the problem to begin with. So what we recognize is that a way to move forward is to actually have a mechanism for assessing the risk associated with any material way before we actually release it for consumption and way before it's actually widely spread. So the idea is to integrate this assessment of risk within the phases of design, synthesis, development, and use. And in fact, during the whole lifetime of the material, to start to think about the material that we make in our labs as a system that is going to have its own life, from the resources that we mine in order to make it all the way to the disposal and the release in the environment after its use. So in order to do this, we have actually taken the scheme of how we make materials, we design them, we develop them, and we find applications and eventually use them. And we've decided to add this idea of assessing them throughout their whole life cycle to try to have an evaluation of the risk. However, doing this is really complicated. It really requires that we talk about toxicity, environmental faith, life cycle analysis, social acceptance, regulatory framework, and I'm missing a bunch here, but you get my point. There's a lot of people that we need to have around the table when we start to do this. It's no longer just us in our little lab trying to make a material. It's a whole conversation with colleagues across the whole campus. And our goal is really to add this last piece, which is to integrate evaluation within the discovery mechanism so that the next generation materials will be inherently safer. So this is, of course, a big challenge, and we separated our research into three axes. One is this idea of inventing new materials and integrating the lessons of assessments and toxicity and evaluation and environmental fate within the design. The second one is to develop a platform in order to have widespread, rapid throughput assessment of emerging materials. And the last one is to involve stakeholders so that everything that we do is driven by the society, the governments, and the companies that are in need of the materials that we're talking about. In order to get started, because this is really nice and very blue sky, we decided to focus on a small number of materials. And we chose them because of some of the expertise that we had on campus, but more importantly, because they're emerging technologies that are in the realm of sustainability already. So one is the field of energy materials, such as lithium batteries, photovoltaics, or photocatalytic solar fuels. And the other one is the field of nanomaterials, which are, we all know, already integrated in consumer products. They are emerging materials for energy catalysis remediation applications, and things like Q-dots, nano carbon materials, 2D materials are going to be the kinds of materials that we would like to work on in order to develop this framework of benign by design materials. So the way we wanted to work for this, it was very complicated because, as Anya said, we want to do things in a new way so that it's really going to lead to breakthroughs in this field. We needed to have more expertise. Just the three of us, George, Neil, and I, we chatted a lot over the summer, and we said, oh, but how are we going to do this? We miss this expertise and that expertise. So what we decided to do was to assemble a team around us who have, we think, the key skills so that we could start to map the problem with the required answers that we could find. So the team is here. So we gathered around us 9 other people. So we're now a team of 12 people. There's Steve McGuire from the Faculty of Management, Jay Ellis from the Faculty of Law, Barbara Hales from the Department of Pharmacology, Thomas Africhis from Chemistry, Nicholas Pravatis from Physics, Subesis Ghoshal from Civil Engineering, Peter Gruder from Physics, Sylvain Coulomb from Chemical Engineering, and Dima Perepishka from Chemistry. So by doing this, we really map what we think is a good representation of the campus with people from a large number of different departments. And what this allows us to draw is a number of skill sets and tools in order to meet the grand challenge that we're facing. So with this in mind, we would like as well our team to be connected with a number of other stakeholders which are key for the success of this initiative. We're going to partner with business, consumers, community, governments, in order to make sure that we're in a position to really tackle the toxicity, environmental fates, life cycle analysis, social acceptance, and regulatory framework of the materials that we are going to study. So finally, I'm sure some of you want to know how to get more involved. So the way we're going to direct our efforts is that all the resources of the theme is going to be towards collaboration, and only with collaboration across the campus. So we're not going to allow 2 persons who are in the same department, have collaborated for many years, to collaborate together. It will be research following the vision that I described. Again, as Professor Gateman mentioned, there's going to be other initiatives. If you feel that you can contribute to sustainability other ways, hopefully new themes are going to emerge in the next few years. And also, it has to be in the framework of the MSSI Grand Challenge. So if you feel that you can contribute to the program as we have presented it with my colleague George and Neil, who's unfortunately not around, you can reach out to us or any of the co-PIs that I mentioned with an idea of how you can concretely provide some expertise in order to address the challenge that I expressed. George, would you like to maybe add a few words?
Maybe 2 words.
Yeah, go for it.
If I may add.
Yeah.
Beyond the specific materials that we have identified to work, what we want to introduce is a new way of collaboration, multidisciplinary, transdisciplinary. We want to break the barriers of collaboration that is not there as much as we want. And in this way, train our new generation of researchers, the PhD students, the postdoctoral fellows, even the undergraduate students, into a new concept of work, because out there, the things are not in isolated boxes, but everything interacts with each other. So we have to learn to work as researchers in this new environment. And this is a great opportunity with this initiative. That's the training aspect and the new value added into that. I think it's a big plus with this initiative.
Thank you very much, Professors Morris and Demopoulos.